I did a couple videos a few days ago looking at these traces from Dirt Diver with Boris's air mode on and off, and I didn't find that there was a huge amount of difference in the things that I looked at. Keyword being the things I looked at. So I looked at the things I normally look at, which are the PIDs and the tuning related stuff. And Boris pointed out that what I really ought to be looking at is the motors and the copter's responsiveness at low throttle. And so I'm going to do another quick video where we actually do that. And one of the things Boris pointed out was, so here we've got a low throttle roll with air mode off. And if we look, here's RC command and here's the gyro. And we see that the stick starts to deflect at about 5.127. And as the stick begins to deflect, full deflection is achieved. So let's take the time from full deflection. Full deflection is achieved 5.3, and the stick returns to center, and the move stops. Let's see, there's the gyro there, right there. So 5.1 to 5.87, so we're looking at about 0.7 to 0.8 of a second, depending on how you slice it. And also take a look at how the motors operate, because we're going to compare this with air mode on. As we're going into the move, here are the motors pushing, and we're coming out of the move, there's another sharp spike. So now let's compare this with air mode on, which is at timestamp 122. Here we've got a low throttle. Unfortunately, we have a dropout right here. That's a real shame. But here the stick begins to deflect at around 122.6-ish. And notice, first of all, that the initial spike is way bigger, way bigger. Also notice that these two motors have not zeroed out like they did. So is that a good thing or a bad thing? I don't know, because in theory you could get more authority by the motors. You could spin faster if those motors actually bottomed out. But in reality, anytime a motor bottoms out, you've lost command authority and you have a greater chance of destabilization. So I really never want to see the motors completely bottoming out. So I would say this is an improvement. Much stronger push into the move, and these two motors are not bottoming out. And how long does it take to perform the roll? 122.6, 123.2. It's about 0.8. So that's not too different, actually. It's not too different. But it sure looks like the motors are more active during the roll, and they're not just sort of pinned against the stops, if you will, with a much bigger stop at the end as well. Let's see if there's another one. There's another low throttle roll. Okay, let's take a look at that one. And this time, let's take it from the moment that the gyro crosses the line. Let's forget about RC command for a minute and look at the gyro. Gyro at 125.3 and 125.9, so about 0.6 of a second there. So it feels to me like maybe the copter's moving a little faster with air mode on, but it sure looks like the motors, if we look at the motor traces, the motors are maintaining a lot more authority and stability as opposed to with air mode off when the motors kind of just get pinned against the stops and then have nothing to do. Let's look at a flip, low throttle flip at 26 seconds with air mode off. Here we go. Low throttle flip. Again, see the purple motor here, motor number 1, I think it is just completely shut down. And in fact, motor number 2, the front two motors are just completely shut down, which means that if at any point you need any, they're just sort of idling at that point. That doesn't seem ideal. There's no way to make them go any slower if you needed them to. We've got a push here. It's going basically to the 50% line, and here we're barely crossing the 50% line. And most of the motors during the move are just almost completely shut down. How long does the move take? I need to get the gyro up. Gyro, pitch gyro. No, no, pitch gyro, please. Pitch gyro and RC command pitch. Here we go. I think you enter the move a little more gradually here. And I think you're already moving forward at the time that you're already pitching forward a little bit at the time that you start the move. So we're cheating a little bit here. You had some momentum going into the move, but from the moment you start pushing forward, where it's about 26.9 to about 27.5, so about 0.6 of a second. Let's see if there's a second one. Nope. Okay, so then we'll do a low throttle flip with air mode on at 140. Here it is. We start the move. Here's where we're starting the move. Yeah, I think about here is where RC command starts to rise. That's 140.3. Just push into the move about halfway up the axis. That's the same. The push out of the move, much stronger, to about 141. 140.2 or 3 to about 141. That's about 0.7. So Boris suggested in his comment that these flips and rolls were faster. The low throttle flips and rolls were faster with air mode on. It doesn't look that way to me. Maybe I'm missing something. Or maybe he meant the high throttle ones, although I wouldn't expect there to be as much difference at high throttle than low throttle, since air mode specifically addresses low throttle. But I do see in the motors that the situation we end up with air mode off, where some of the motors are just completely shut down, is not happening. The motors are staying active, and to me, and also it's not a scientific comparison, because this spike here could be higher just because you drop the stick faster. So I mean, it's not, we don't have a robot operating the sticks, but the fact that the motors are staying active here does seem to me like a good thing. Here again, we got another one. Big push in here, big push in. You're probably doing about the same thing with the sticks. So the fact that we see a much bigger push here is probably due to air mode being more authoritative at low throttle. 141.5 to 142.2, so that's about 0.7. Yeah, all of them seem to be taking about 0.6 to 0.8 of a second. The motors are much more active though. And if we look at zero throttle, let's look at this long no throttle drop. One last thing here, 51 seconds. Long no throttle drop at about 51 seconds. So you drop the throttle here, you do your flip. Now the stick is centered, the throttle is down. And if we look at these motors, notice that the yellow motor and the red motor are almost completely shut down through this whole drop. Right now, so they're not helping you gain authority. The other three motors are doing all the work. And if we look at long no throttle drop with air mode on at 132. And there we go. Notice that the motors are more active. And that's probably the main thing that is, even the red motor, which kind of almost gets shut down somewhere in here, is still kind of active. So it feels to me like that's probably contributing to the more locked in feeling that people are reporting. And I'm happy, because now at least if we look at the motor traces, we do see a difference that helps us characterize what air mode is doing differently. The motors are definitely behaving differently, even though if we look at the PIDs, they kind of look the same. Something's happening between the PIDs and the motors, which of course is the mixer, and that's where all this magic is happening. Alrighty, well, hope that was helpful. Bye bye.